Hi, welcome back. This is still Ken. We're still in lesson 2 on motion along a straight line. In this video, we're going to have some examples on our previous discussion on motion with constant acceleration. As a short review, we have here the equations of motion with constant acceleration, which we have derived in our previous discussion. The four equations shown to the right apply to any straight line motion with constant acceleration A. Our first equation is Vx equals v naught x plus axt. Our second equation, x minus x naught is equal to v naught xt plus 1 half axt squared. Our third equation, we have 2ax times x minus x naught, and this is equal to your vx squared minus v naught x squared. And lastly, our fourth equation is x minus x naught equal to 1 half vx plus v naught xt. The use of this equation will vary depending on what are given in our problems. In the next slides, we're going to show some examples on how we are going to use these equations. For our first problem, the jeepney driver applies a brake giving a constant acceleration from a velocity of 23.6 meters per second to 12.5 meters per second over a distance of 105 meters. For the problems, how much time elapses during this time interval? What is the jeepney's acceleration? If we were to continue braking with the same constant acceleration, how much longer would it take for him to stop? And how much additional distance would it cover? Let us analyze the question carefully. The jeepney driver applies a brake giving a constant acceleration. So we have constant acceleration here. So from the problem itself, it is clear that we are going to use four equations of motion for constant acceleration. The jeepney driver applies a brake giving a constant acceleration from a velocity of 23.6 meters per second to a velocity of 12.5 meters per second over a distance of 105 meters. Here, our given are, we have your initial velocity, v naught, which is equal to 23.6 meters per second, and we have your velocity, your final velocity of 12.5 meters per second, and we are given with a total distance covered of over 105 meters. So this is your x minus x naught is equal to 105 meters. If you're going to look at the problem, consider this point here as our region at x naught, which is at 0. You have here your velocity v naught. Now, as the jeepney driver applies a brake, giving a constant acceleration, the jeepney covers this total distance here, which is of 105 meters measurement. This is 105 meters. And at this point here, you have your x and your velocity, which is equal to 12.5 meters per second. So our first target is how much time elapses during this time interval. So we are asked here of the time t, for which the jeepney covers this total distance. Let us look into our four equations of motion to see which of this equation we can use to solve the problem. Let's look first into our equation number 1. For equation number 1, your equation includes your velocity v, your initial velocity, We have acceleration and then the time. You're looking for the time. You're given with your velocity v and then your initial velocity. However, we do not have the acceleration as we don't know it yet. Therefore, we cannot use equation number 1. How about equation number 2? For your equation number 2, you have your x minus x naught, you have your v naught x, you have your time, you have your acceleration, and then your another time. Here, we still have your acceleration, which we are not given yet. Therefore, we still cannot use equation number 2. For equation number 3, we still have your acceleration term, and we do not have the time term. Thus, equation number 3 cannot be used also. Equation number 4 has your x minus x naught. You're also given with your v, and then your v naught, and then your time. You have your x minus x naught, that is checked. You have your velocity v, and you also have your initial velocity. And our target is time. Therefore, we can use equation number 4. Let us continue solving the problem. Solving the problem by using equation number 4, you have your x minus x naught is equal to 1 half v minus v naught times t. Let me just remove the sub x. Our target here is your time t. Doing some algebra, we multiply both sides by 2. So you have 2x minus x naught. And then dividing both sides by the term v minus v naught. So you have here your v minus v naught. And you're only left with your time t term. So your time, this is equal to 2 times 105 meters divided by 12.5 meters per second plus 23.6 meters per second. Solving the problem, your time is equal to 5.82 seconds. You can pause the video to review the solution. Now let us proceed to the second problem. What is the Jeepney's acceleration? In the previous slide, we have already solved problem A, and our time was equal to 5.82 seconds. We still have the same given. You have the initial velocity, v naught, which is equal to 23.6 meters per second. And we still have the same final velocity v of 12.5 meters per second. And this time we have now an additional given of time, 5.82 seconds. What is the Jeepney's acceleration? So let us look at, or here our target is the Jeepney's acceleration A. Let us look at your 4 equations of motion and see which of the following equation we're going to use to solve the problem. Our target is the acceleration. So by looking at your equation 1, we have the given v, we have also v naught, and we also have your time t, and our target acceleration. So we can use equation 1. Of course, we can also use equation 3 because you also have your x minus x naught, and equation 2. But let us just use equation 1. So we have v cos v naught plus at Solving for the acceleration, we have v minus v naught. This is equal to at divided by t. Divide this one by t. So your acceleration, this is equal to v minus v naught over t. This is equal to 20, or sorry, this is equal to 12.5 meters per second minus 23.6 meters per second divided by 5.82 seconds. We have an acceleration of equal to negative 1.91 meters per second squared. Our acceleration is equal to, again, negative 1.91 meters per second squared. Now let's solve problem C. If you were to continue braking with the same constant acceleration, how much longer would it take for him to stop? In this problem here, we're referring to the previous acceleration, which we have solved, and that acceleration was equal to negative 1.91 meters per second squared. So if you were to continue braking with the same constant acceleration, how much longer would it take for him to stop? Here, we're asked of the time t. For your jeepney to stop moving. Here, if you still take your v naught is equal to 23.6 meters per second, our v now will be at 0 because we're asked for the time it would take for the jeepney to stop. When we are talking about stopping, this means that you have your velocity is equal to 0. So your final velocity is 0. And we're still given with the same acceleration of negative 1.91 meter per second squared. Here, our target variable is the time it would take for the jeepney to stop. Looking back into again our four equations of motion, we look for equations wherein there is a time variable. Of course, you have here your equation 1. We have the given v, we have your v naught, we have the acceleration, we have the time. So we can use this one. However, we cannot use equation 2 because of this term here. Remember that we do not anymore know what is your x minus x naught until your jeepney will stop. The same is true here. Also this equation here. So we can only use equation number 1. So let us solve the problem. You have your v is equal to v naught x plus 80, or yeah, let me just remove the x, make it cleaner. So our target here is the time t. So solving for the time, you have your v minus v naught is equal to 80. You divide by a, cancel out. So we have your t is equal to v minus v naught over a. Our velocity final is just 0. So we have t is equal to negative 23.6 meters per second divided by negative 1.91 meters per second squared. Solving for the time, you have your time t is equal to 12.36 seconds. So we're down now to our last problem, and it asks us for how much additional distance would the jeepney cover? Okay, in the previous problem, we're able to solve the time t, which is 12.36 seconds. In this time, how much additional distance would the jeepney cover? Okay, so we are looking for the additional distance. We are given with, again, your V naught is equal to 23.6 meters per second. You have your V is equal to 0, acceleration of negative 1.91 meters per second squared, and then we have now the time T, which is equal to 12.36 seconds. Here, our target is the additional distance. You have your x minus x naught, or this is the total distance covered. But your additional distance is equal to your x minus x naught minus your 105 meters. This is the additional distance. Okay, let's solve the problem. Can we use equation number 1? It is obvious that your equation number 1 do not contain the x minus x naught term, so we cannot use this one. How about equation 2? You have your x minus x naught term, you have your initial velocity, we have also the time, we have the acceleration, so we can use equation 2. We can also use equation number 3. Also, we can also use equation number 4. Again, you can use any of these 3 equations and it should give you the same answer. Let me just use equation number 2. You have your x minus x naught, which is equal to v naught t plus 1/2 at squared. So this is equal to 23.6 meters per second times 12.36 seconds plus 1/2 your negative 1.91 meters per second squared times your 12.36 seconds squared. Your x minus x naught is equal to 145.81 meters. Your additional distance then is equal to your 145.81 meters minus 105 meters, which is equal to 40.81 meters. Problem solved. Let us have another example. This is about a motorcycle with constant acceleration. A motorcyclist heading east through a town accelerates at constant 4 meters per second squared after he leaves the city limits. At time equals 0, he is 5 meters east of the city limits signpost, moving east at 15 meters per second. This is how the problem looks like. After the motorcyclist leaves the city limits, which we can say as your x equals 0 or your origin, the motorcyclist accelerates at constant 4 meters per second squared. At time equals 0, he is 5 meters east of the city signpost. So at time equals 0, you can consider your x naught to be equal to 5 meters. This is your time equals 0, and then your x naught equals 5 meters point. At this point, your motorcyclist is moving east at 15 meters per second. So he has an initial velocity of 15 meters per second. Again, he moves at constant acceleration of 4 meters per second. Our problems are: find his velocity, his position and velocity at time equals 2 seconds, and B, where is he when his velocity is 25 meters per second? Let's solve the problem. In this problem, we are given with your x naught at time equals 0, which is equal to 5 meters. As you can see here, your x naught is not always equal to 0. It depends on where or when your time is equal to 0 is. So you have your x naught is equal to 5 meters. Another given is you have your constant acceleration of 4 meters per second squared. And we're given with the initial velocity of 15 meters per second. For problem A, we have an additional given of time is equal to 2 seconds. Our target here is his position and velocity at time equals 2 seconds. That means your x and v at t equals 2 seconds. Which of the four equations can we use? We can use equation 2 to solve for x, and we can use equation 1 to solve for the velocity v. Finding for x, you have your x is equal to x minus x naught. This is v naught x t plus 1/2 axt squared. We're only solving for x, so you have your x is equal to x naught plus v naught xt plus 1/2 axt squared. Your x is equal to 5 meters plus 15 meters per second times 2 seconds plus 1/2 acceleration of 4 meters per second squared times time 2 seconds. Sorry. Yeah, times time 2 seconds squared. Your x is equal to 43 meters. We use equation 1 to solve for the velocity. So your v is equal to your v naught x plus axt. You have 15 meters per second plus 4 meters per second squared times 2 seconds. Your velocity v is equal to 23 meters per second. So 2 seconds later, at this point here, your motorcyclist has already or is at x equals 43 meters from the signpost and is traveling at velocity of 23 meters per second to the east. Thus, your motorcyclist is still speeding up or is continuously speeding up. Let us solve for problem B. For problem B, we are asked where is he when his velocity is 25 meters per second. So for problem B, our target is the x position at velocity is equal to 25 meters per second. Again, we have your initial velocity, v naught. This is equal to 15 meters per second. We also have the acceleration of 4 meters per second squared. And your x naught is equal to 5 meters. Our target is your x at velocity equals 25 meters per second. Let's look at the four equations to see what equation we are going to use. Can we use equation number 1? Your equation number 1 contains the term t, which we are not given, so we cannot use this one. The same case with equation 2, because this also contains your term t, so we cannot use this one. Also with equation 4, it has the term t, so we can only use your equation number 3. Let's solve the problem. We have 2ax, x minus x naught. You have bx squared minus v naught x squared. You want to find your x, so we take this out of the equation. So you have x minus x naught, and dividing both sides by 2a, we have bx squared minus b naught x squared divided by 2ax. Taking out or transposing your x naught, you have your x is equal to x naught plus bx squared minus v naught x squared over 2ax. You can solve this one on your own, and you should get an x of 55 meters. Please confirm it yourselves. Please see if indeed we get an x of equal to 55 meters.